Hello and welcome to today's session. Today's session will focus on to understanding the differences between AI, ML, DL and generative AI. So did you know 77% of devices today use AI technology in one form or the other? 60% of videos we watch on YouTube are a result of AI recommendation. 40% of the apps installed from Play Store are a result of AI-driven recommendations. AI can accelerate business productivity by 40%, and it's estimated that by 2030, AI will add $15.7 trillion to the world's GDP. So let's try to understand in today's session what are the fundamental differences between AI, ML, DL, and generative AI. So AI is a key pillar of computer science. It represents a complex and dynamic field, and it has a wide range of techniques to empower the machines that will be very analogous or similar to the human cognition. Machine learning is a subset of AI. It is primarily concerned with interpreting the patterns within the data sets. And because of the recent breakthrough in the domain of computer science and parallel computing, it helps to handle and analyze these voluminous data sets, which are very important in machine learning. Deep learning is in turn a subset of machine learning. It operates through neural networks. Deep learning basically is known to handle larger data sets, and it performs far more complex computations as compared to machine learning, and it utilizes intricate neural networks to achieve this objective. Nevertheless, there's a significant difference between ML and DL. And generative AI is a branch or a subset of deep learning again, where we used generative AI to produce new images, new outputs. Let's first try to understand machine learning. See, machine learning basically had of two types. Actually four types: supervised, unsupervised, semi-supervised, and reinforcement learning. Today's session will just see an introduction to supervised and unsupervised learning. In supervised learning, the algorithm is trained on labeled data sets. So this is the algorithm. The algorithm is trained on labeled data sets. Labeled in the sense you give images, suppose like this, which consists of pears, apples and mangoes, and you label them and say that this is a pear, this is an apple, and this is a mango. So the algorithm learns from the labeled images, and when you give an output, it recognizes that this is an apple, this is a pear, and this is a mango. In unsupervised learning, the algorithm is fed with data which is unlabeled. So that means you just give all these fruits, you don't label them. So the algorithm tries to understand the patterns within this image and then finally gives the output based upon the similar patterns in the input image. Deep learning, on the other hand, utilizes a form of supervised learning where it works on deep neural networks, right? The neural networks here are composed of multiple layers of interconnected nodes which are designed to hierarchically process the data. Each layer in the neural network will extract features from the input data, which are then given to the subsequent layers to further refine the output. So deep learning algorithms have the capacity to learn from unstructured data. Like it can be, the input can be images, it can be audio, it can be text, and therefore it's a very versatile, makes deep learning very versatile, and therefore has huge applications in image recognition, speech recognition, and natural language processing. However, there are some important differences that we need to understand between machine learning and deep learning. Machine learning basically has very good interpretability, whereas deep learning has very less interpretability. In the sense, in deep learning, the algorithm learns because of the neural networks. So when you get a particular output, it's very difficult to actually explain how the algorithm took the decision. Whereas in machine learning, it has good interpretability. In the sense, suppose I'm using a decision tree algorithm in machine learning, right? When you get where the decisions are taken based upon a set of rules. So when a particular output is obtained, it's easier to try to understand that how this output was obtained because of the algorithm by analyzing the series of rules which were used in the if-then statements of decision tree algorithm. However, deep learning is very popular because of the remarkable performance, remarkable precision, accuracy that it generates. However, deep learning is also very computationally demanding. Since it works on complex neural networks, it is computationally very demanding. In contrast, machine learning also gives good level of accuracy and performance at a fewer computational resources. So despite these differences, machine learning is also very effective and very good for various applications. Generative AI, on the other hand, is a subset of deep learning. Generative AI is designed to produce new text, new images, or code-based textual or visual inputs. There are two leading frameworks in generative AIs, GANs and GPTs. GANs stands for Generative Adversarial Networks. GPT stands for Generative Pre-trained Transformers. Now, GANs was actually a concept which was devised by Ian Goodfellow in the year 2014, where it has two models, basically generator model and a discriminator model. So GANs has two models, generator model and discriminator model. Generator model is tasked with creating new content, while discriminator classifies this content as real or counterfeit. GPTs, on the other hand, is primarily employed for generative language modeling. It is used for generative language modeling. It is used to generative AI's main objective, the generative AI's main objective is to emulate the human interaction. So it is a blend of supervised and unsupervised learning. So let's try to understand some of the use cases of machine learning. See, machine learning has huge amount of applications like in image recognition, where you can use it to identify the objects, people or patterns. You can use it in natural language processing to understand the human language or sentiment analysis. Speech recognition, where you can actually convert the spoken language into text. In recommendation systems like in e-commerce or movies recommendations, streaming platforms, anomaly detection, where we can identify unusual patterns and can use this for fraud detection. We can use it for cyber security. Deep machine learning is also very good for predictive maintenance, predictive in the sense where you can actually predict when some equipment or machinery may become faulty, and therefore very good for manufacturing and industrial settings. In credit scoring, where the machine learning algorithm can be used to assess the credit worthiness of individuals. Healthcare diagnostics, where you can use ML to diagnose the diseases. Autonomous vehicles for enabling self-driven cars. Language generation, fraud detection, virtual assistant, stock market prediction, customer segmentation, and many, many more. Similarly, deep learning also has a lot of applications. Image classification, where you can use it for classifying the objects, scenes, or animals in an image. For natural language processing, speech recognition, object detection, facial recognition, and recommendation systems. Semantic segmentation, where assign a semantic label to each pixel in an image. For style transfer, where we transfer the style thereby image to another, thereby creating artistic effects. We can use it for drug example. DeepMind's AlphaGo is an example of game AI which uses deep learning. Chatbots, music generation, many more, and many, many more. So therefore what we can understand that there's a clear difference between AI, ML, and DL, and each one has their own a very powerful technologies and having wide range of opportunities. If you understand these algorithms, there's a wide range of opportunities that so let's try to delve into this field of ML, DL, and AI and try to understand the concepts of and the fundamentals of these technologies. So in the next session, we will begin with the ML session. We'll try to understand the fundamentals of machine learning, and this complete series of tutorials is focused on machine learning. We'll completely try to understand as many as possible machine learning algorithms and implement the same thing using real-time scenarios. So thank you so much. Please subscribe to the channel, and please watch the next video where we will be discussing about machine learning fundamentals. Thank you so much.